Students, in this video I'll be discussing about the different types of graphs which are required in the motion chapter for class 9. So first we'll be discussing about different types of distance time graph. Now in order to draw graph, you need some values. So I have taken some values as an example. So based on those examples, we'll draw the graph. I could have drawn the graph directly and told you that what that graph stands for. But if you have the values, it will be easy for you to visualize actually how to draw the graph. So in the first case, I have taken the distance. The value of distance is in meter and time is in second. So I have taken the distance covered by the body to be 2 meter, 4 meter, 6 meter, 8 meter and 10 meter in time 1 second, 2 second, 3, 4 and 5th second. So all these values, so for a graph you have to draw an x-axis and a y-axis. So in the x-axis we have to take time with respect to what that you have to take in the x-axis, because there is distance traveled with respect to time. So with respect to time, so time we are taking in the x-axis and in the y-axis we will be plotting the distance. Now when you plot any graph, you should be careful that equal distance should indicate equal gapping. So like for example here, the distance between two lines, I have taken it to be 2 meter. So the next distance between two lines, again 2 meter, that means 4 meter. Again next gapping will be 6 meters, so on. Your values can be anything. But when you take the gapping, when you mark in your graph, that should be of equal values. The gapping should be equal. That you have to be careful. So I plotted accordingly. And when you plot, you should be careful that your values get a good representation. Suppose my values here are 2, 4, 6, 8 and 10. So there is a gapping of 2 each and it begins from 2. So first gapping, if you write 100 here, 200 here, then it will be very difficult for you to plot 2. So your plotting here should be according to the values. You should keep your values in mind while giving the values along your axis. So when we plot, like the first point is 2 meters in 1 second. Next value is 4 meter in 2 seconds. 6 meter in 3 seconds. So like that I have plotted the points first. And if you find difficulty in plotting the point, then you are advised to draw dotted lines from both the axes, and where both the dotted lines will meet, there you put your dot. Now after plotting the points, then we will draw a straight line joining the points. What we find for these values given here, the line is a straight line. So this particular kind of distance time graph indicates uniform speed. Now why uniform? If you take the numerical value here, 2 meter in 1 second, so distance by time, s by t is your speed. So 2 by 1, so the speed is 2 meter per second. Similarly 4 by 2, again the speed will be 2 meter per second. 6 by 3, again the speed will be 2 meter per second. So what we find is that the speed remains constant. So it is a case of uniform speed or constant speed. Next, we come to the second graph. Here I have taken the values as example to be 2 meter, 5 meter, 9 meter and 14 meter. Time interval I have taken 2 seconds, 4 seconds, 6 seconds, 8 seconds. So this is just an example. So when I have drawn the graph, you see the marking here, the gap between two lines I have taken as 2 meter. So the next gap again will be 2 meter, so 4. Next gap will be 6, though there is no value of 6 here, but the next gapping here will be marked as 6. After that I will find out 5, where 5 will lie. So the gapping should be equal. Have you understood the concept, how to draw the graph? So after I plot both the axes, now I will be plotting the value. So what is the first value? 2 meter in the first 2 seconds. So I plotted that. Next is 5 meter in 4th second. So where will 5 lie? 5 will lie somewhere between 4 and 6. So I have in between 4 and 6, I have drawn the dotted line indicating 5 in how many seconds? 4 seconds. Next value is 9. So 9 will lie somewhere between 8 and 10. So the midpoint I have taken, I have plotted. So that way I have plotted. 14, already a marking is here. So when I join the lines, the dots, I'll find that the graph line is a curved line. It is not a straight line. So it is a case of non-uniform speed. And why it is called speed, I am again repeating, because distance by time Theoretically, we know it is about speed. So you should remember, for any kind of graph, if you get a straight line, it always indicates uniformity in motion. And if the graph line is not a straight line, the motion is not uniform. Next we come to other kind of graphs. There is another distance time graph I have for you here. So here you find that the distance traveled by the body in the first second also 10 meter, second second also 10 meter, third second also 10 meter, fourth second also 10 meter. And see, now all the values are 10. So what I have taken along the graph, I haven't taken 2, 4, 5, 6 like that. Since the value is 10, so one in between I have taken as 5 in a 2-line gap. And again in the next 2-line gap I have taken. So it is in multiples of 5 that I have taken. So that you will take according to your convenience, depending on the values given. You can directly take only one value 10. That also doesn't matter. However, the graph line, after plotting all the points, I find after joining the dots, I find that the graph line is a straight line parallel to the time axis. So such a distance time graph which is parallel to the time axis, it indicates that the body is at rest. Why the body is at rest? Because with increase in time, the distance traveled by the body is not changing. That means in the first second also the body is at 10 meters from me. At second also the body is at 10 seconds from me, and in the third second also the body is at 10 meters from me. So overall position of the body is not changing. So we say that the body is at rest. So these are the 3 types of distance time graph. Now when we come to velocity, the next kind of graphs are velocity time graph. So first graph is, so velocity I have taken in meter per second, time in seconds. So the first values, example I have taken 20 meter per second, 20 meter per second, 20 meter per second, 20 meter per second. In how much time? 1, 2, 3 and 4. So velocity by time, any velocity time graph, what it will give you? It will give you acceleration. Okay, so because velocity by time, that is your acceleration. So if someone asks you what we get from the velocity time graph line, your answer will be that from a velocity time graph line we get acceleration of a body. So what we find here, after plotting the points given here and joining, we find that the graph line is a straight line parallel to the time axis. So such a velocity time graph line which is parallel to the time axis, it indicates constant velocity. Why constant velocity? Because in the first second also the velocity of the body is 20 meter per second, second also it is 20 meter per second, third second also it is 20 meter per second. It's not that. So in practical sense, if we find the speedometer, it is neither going up nor coming down. It is fixed where it is. That is when you are driving on a highway, you are not pressing the accelerator, you are not leaving the accelerator, you are driving at constant speed. So it is a case of constant velocity and the acceleration is 0. So how 0 acceleration? Let us see numerically. Suppose this is the first case, this is the second case. So let me take, this is the final velocity. So I take the 2 cases here. So here the final velocity acceleration is what? V minus u by t. So here the final velocity is 20. Here the initial velocity is 20. And what is the time gap? Time gap is 1 second. So it is 0 by 1. So the acceleration is 0. What is acceleration? Change in speed or velocity. Here your velocity is not changing with time. Therefore, it is a case of 0 acceleration. Now this graph has a same meaning as this distance time graph. Here also we are finding what? That the speed is constant. So this distance time graph has the same meaning as this velocity time graph. Don't think that this graph and this graph is the same. No, this is a body at rest distance time graph and this is a velocity time graph where the body is not at rest. It is moving with a constant velocity. Acceleration is 0. Okay. Next we come to the other kind of velocity time graph. I have taken the values because just to give you an idea so that you can visualize. So here what we find that the velocity is increasing. First it is 3 meter per second, 6 meter per second, 9 meter per second, 12 meter per second in time interval 1, 2, 3 and 4 seconds. So when I'll plot the velocity time graph, It is very important to write these things in the axis. So I will, after joining the points, I will get a straight line with an increasing slope. So a velocity time graph which is a straight line with an increasing slope, this is decreasing slope. With an increasing slope, it indicates uniform acceleration. Now let us see how it is uniform acceleration. Theoretically, then practically we will try to understand. Suppose I take this gap. So acceleration is v minus u by t. So here final velocity is 6, initial velocity is 3. And what is the time gap? 1. So 6 minus 3 is 3. 3 divided by 1, that is your 3 meter per second square. So this is the acceleration. Here let us see the gap. Here the final velocity is 9. And the initial velocity is 6. Time gap again between 2 to 3 seconds it is 1. So 3 by 1, that is your 3 meter per second square. So what we find that the acceleration is uniform or constant. We can also write constant acceleration. Is that clear? So when the speed or velocity increases, so practically if you try to visualize, you will find that your speedometer is increasing like this, and it is increasing at a very uniform rate. So that is an example of uniform or constant. At a constant rate, the body is accelerating, its speed is increasing, velocity is increasing. These things generally happen when there is no traffic on the road, the body is going on the highway, there is no thing to bring down the speed, there is no other traffic present. In such cases, such kind of graphs are possible. Now if you are moving in a marketplace, obviously at some point you will accelerate, at some point you will decelerate, so your graph will not be an uniform one. This one, in the first second it is 40 meter per second, in the second it is 30 meter per second, third second it is 20 meter per second. So what is happening to the velocity? It is decreasing over time. So if you plot the graph, the points, you will get that it is a straight line but with a decreasing slope. So it is a case of uniform retardation. That means negative acceleration but occurring at an uniform rate. I told you, anything which is a straight line, it shows uniformity. How? Let us see. Let us take this gap. Here the final velocity is, final velocity means the velocity at the end of the time. So here the final velocity is 30. Initial velocity is 40 divided by time is 1. So it is minus 10 by 1. So it is your minus 10 meter per second square. Now let us take this gap. Here the final velocity is 20. Initial velocity is 30 divided by time gap is 1. So again minus 10 by 1. So minus 10 meter per second square. So what we find? It is negative, case of negative acceleration, but the rate is uniform. That's why it is called uniform retardation. So with values I have explained too many graphs. So directly now, since we have developed the concept, so if the values will not be uniform, so what kind of graph can we accept? So if the velocity time graph is like this, it is having an increasing slope, it is increasing but not a straight line, then it is a case of non-uniform acceleration. And if it is a decreasing slope, here with respect to time the slope is decreasing, then it is a case of non-uniform retardation. So these are the overall distance time and velocity time graph that you have to know at class 9 level. Now one more thing you have to remember, if you can understand well and fine, otherwise it's not so important. Suppose we have a distance time graph, distance in meter and time is in second. Now you should remember, a distance time graph can never come like this. It can never have a decreasing slope. Why it cannot have a decreasing slope? Suppose there is a point. In the first second, suppose you have gone 10 meter. In the next second, suppose you haven't gone 10 meter but you have gone just 2 meter. So the distance you have traveled has decreased compared to the first one, but overall distance, it is 10 plus 2, that is 12. So as you keep on traveling, the distance of a body never decreases. It will keep on increasing. So your graph will be, let's say, first second you have traveled 10, so your graph will have a more slope. In the next you have traveled 2, so your graph line may flatten like this, but it will never come with a decreasing slope. It will keep on increasing depending on the distance covered. So a distance time graph can never have a decreasing slope. That you have to remember. Thank you.